Okay, so hello to each and everyone. My name is Karan Gupta, and today I would like to discuss a bit about SolidWorks and how we can just quickly design some of the things, some of the components in journal, and it's more related to the computer-aided designing part. So where we will just simply design the components, do the assembly part of it, and then we can do the analysis. So the next screen that you will see right now will be of the SolidWorks interface. So particularly what exactly we do in SolidWorks is, as I told earlier, we try to design the part. So now we can design either through different options available here, and we can even show a lot of creativity in this particular software, like how quickly we can design, how what exactly we think about the designs here. So we will also see like SolidWorks has a capability to do simulations, but they are very limited. I mean, you can do the static analysis, more about the implicit part of it. When you talk about the time integration of the explicit code, then it's a bit harder to do it in simulations. That we will see later, the same product, the same part or design in some other softwares, how we can take it from here and then do the analysis part. So just to let you know a quick interface. So this is like where this is a very introductory video where we will only see the simple how we can do quick geometry creation, and later on we will also see some of the other parts of it. So for example, we can quickly sketch in the sketch window. We can check it out the smart dimensions, do the different type of AutoCAD here, and a lot of other things are available, other features are available. So we can do the extrude and each and everything. So why not to do a quick sketch? So let's say if I have to draw, we have to just click on sketch and we have to select a plane particularly. And then let's say if I have to design a rectangle from the center, I just select and just give it here. So make sure like you always try to give a dimension here, so you can give like 150 for this design, and let's say this is 100 meter in length, 100 millimeter in length. So we also have to decide the units here that we can check it from the downside. Again, let's say this is a AutoCAD generated. If I have to make it a 3D model, we just simply go to the extrude boss base, and here we can just either give the blind or like totally depends like what exact where you are just applying it through, and you can just give any of the extrusion dimensions. So let's say if it's 20 units, I have given it. Now let's say the 3D part is created, and we can do a lot of things later on. We can do the for the highly complicated stuff, so you can use a swept boss base, a lofted boss base to make like pipes design and each and everything. Everything is possible here at in particularly in SolidWorks. We can do fillets, we can do linear pattern, circular patterns, ribs, each and everything. Also, let's say if I have to make an extruded cut, so again I have to select a plane. This is really important. So once you select the plane, you have to select here and just make it into the direction where you want to make it. So let's say again I have to cut it like from here, another one. I just simply say okay, I want a cut here. So then it always asks like how much cut you want. So blind means it will take its own dimension, but if I say through all will just cut the whole part of it, like where whatever is the distance that we have defined here. So this is how like we can quickly create one of the part. And for higher let's say geometries for complicated parts, I will certainly put on some more videos to understand what exactly is the how to do patterns, shells for surface modeling, as well as wireframe structures. Each and everything is good enough. Make sure whenever you try to learn this tool, you also have to have a good understanding of engineering drawing. So like first angle projection, third angle projection. So how to read the drawings, like if it is in first quadrant, like what are the different views that we take into account, how we just put it into the sheets. And this is what exactly the industry needs. So make sure you know each and everything. If you are really new to it and want quick introduction part of it, please do let me know. I will make sure to put on some videos. So why not to start this session with a quick example. So I will take a medical example. So we all know about medical syringes. So why not to create the medical syringes and do a bit of the exploration of more about SolidWorks. So I have already designed it. So I will try to open the part. Uh, so let's say in syringe we have three different parts: barrel, stopper, and plunger. So let's open the barrel part first. So I will just quickly let you know how I designed this barrel. So this is a barrel where like the syringe is like the liquid is going to get filled up. So how I have designed, as I told you about the revolve as well as the extrude boss space. So what we have to simply define a geometry. Let's say the blue part, whatever we see here, this one, the blue part is a geometry that I have defined for this part, and what I did is revolved around an axis. So that's how you just get a full structure or full part of it. So that's how we generally used to design this part. Any complicated part, you give like chamfers, you give each and everything. Now the another part we can just quickly try to see. I will like to open it. Is the plunger. So here is the plunger. Here it is. Again, I did the same part, but I did some more edit features here. Like, I added, let's say, the linear pattern. So I will quickly like to show. Like, this is the initial part. If you remember, what I did is I defined this black part here. I defined the geometry, how I want it to be. Make sure the dimension should be correct. That's where like things comes into the action when we go to the assembly part. We will see today so quickly. And this is how I just created this part. Again, I just talk about the linear patterns. So I just simply go to the pattern part here. So hold on. So this is only what I defined as one part, and then I did the pattern of it into 90 degree, like four parts. So I just simply go to the pattern. So this is what I just did it for this part, and that's how I just defined the plunger. Now another part is the another last part for this particular medical syringe is it's not new. This should be, let's open it. It's a stopper. So we already have a stopper here. Okay, and say no. Okay, so I have this. Just let me do some issues. Yeah, okay, so this is the part here, and this is what I have defined. Hold on. And what exactly we have to do again, it's a very simple case. So this is an I mean the quadrant part of it. So we don't need the quadrant one. So let's say what I did is like we go to the sketch and again define the part that I need to define. Again, the dimension makes more sense, and then I revolve it and make it like the extra revolved boss base, so that I can just get this whole part. So I can just make delete this extruded part so that one can understand how exactly the part is run. So this is the actual part that earlier that we saw was more related towards the quadrant of it. Whenever we talk about the symmetry, there we will take into this section. Okay, so this is all about it. So why not to study a bit about when the assembly part of it. Let's say we go to the new. We can first make it say, okay, there's some issues. So okay, I want to replace it. It's okay. So let's say we go to the new part where we have to do the assembly, and for assembly we have to import all the defined parts in journal. So I have all this part, or apart from that you can just go to the browser, select all the three parts that you have made it, and then you have to define them one on one. This is second, and this is the third. So this is how like all the three parts are defined in journal, and now we have to meet them. We have to just connect all together. Simply go to the meet part here. And let's say when initially I want to define the stopper on the plunger, I select this part and I select this part, and this is how it is. It comes aligned here. And what I want is like this part should be connected with this part. So again, I select this part here. I want it exactly to be here. And that's how we just define on plunger our stopper. Now what we want, like the whole of this part should go inside it. So let's say I define this section of it and it should be inside. Let's say should be here. So that's how like the simple assembly came into the action. So let's say if I have, since this part is overdrawing the barrel, I mean the plunger is overdrawing, so we can just simply move the component while selecting the component, and we can just simply see, yeah, now it is not overmoving. Okay, all fine. So this is what we did so far, and we also have an exploded view. So sometimes we can define it through exploded view, and also we can define the different color of our part. So we can just simply go here. So let's say my part, like the barrel should be of any, I can just create of any color right now for the visibility. Screen, and then plunger, I just want it like let's say of any of the color of our choice, and let's say it's going to be red, and let's say by default whatever is the color of stopper, let it be. We go to the exploded view. For exploded view we have to define like the how things are connected or it's working. So just to give you an idea, so I just select let's say this part, and I want it to be here, and that's it. So what exactly we can do with this particular exploded view, we go to the configuration and we just try to animate the collapse. So this is what exactly it looks like in journal. So we can play a lot with this design and each and everything. So what I simply recommend you guys is to do a lot of practice, and if you really want me to add some more videos, I will be more than happy to add here and try to give you more information about it. So that's it about this video. So everything is all about this video, and we have seen like how to do each and everything as a quick session, and thank you so much.